Hello, and welcome to my video. This is about Calc 2, Section 1. The first section you go over. First section you learn in Calc 2. It's easy, but I can make it even easier to understand. Now, this video is for you students out there struggling with the first section right off the bat. It's very easy, and it can be a little fun to do these problems because the problems you will get to in the future are going to be, well, let's just say they're going to be scary. This, however, I can make it unscary, not scary at all. Now, this is an integral, an improper integral, and we're going to solve. We're going to solve it easily, too. Now, the first thing to do is to take the u substitution. Now, whatever you do when taking a u sub, if you have a square root, you should always do what's in the square root as the u sub. No matter what. No matter what integral you're given, I don't care what's outside of this square root, always take what's in the square root as the u sub. It'll make it a heck of a lot easier to deal with this square root. Heck of a lot easier. Now, in taking the u sub, we make the u equal to 11 plus x cubed for this problem. Now, this u will replace 11 plus x cubed in the square root for our integral. But that's not the only thing we need to do. We also have to take the derivative of u. So the derivative of u, since 11 is a constant, it equals 0. So, or it equals 1 really, but it doesn't really matter. So we can ignore it. And we can take the derivative of this, x to the power of 3. Just use the power rule. So the power rule is we take that 3 and we put it in front of the x, and then we minus that power by 1, giving it 3x squared. And then we put dx right next to it. Easy. But this is a way to use this u sub in a better way. And this can work for even more complicated integrals than this one. Now, because we have this x squared here, we can, in fact, divide both sides by 3. And then we get du over 3 equals x squared dx. Now this wouldn't work if we didn't have this x squared here. So it's a good thing we do, because we can replace x squared and dx with du over 3. Easy, simple. And we replace the u, 11 plus x cubed, with the u. So this is our new integral. That's going to be easier. Now, first thing we got to do if we do anything is get rid of this 3. We don't want it here. We just move the 3 so we can get x squared dx. That's the only reason we did this. So in order to get rid of that 3, we just put it in front of the integral as a fraction. So you get 1 over 3 times the integral of the square root of u du. Easy. Just move it out in front and put a 1 on top of it. That's all you gotta do. It's not rocket science. It's easy and it's fast. So the next thing we do is we still keep that 3 But this square root, if you know what it does to you or anything, it's this. It's that square root basically means u to the power of 1 over 2 du. That's all it really means. The square root can, if it was a power, it would be 1/2. That's all it means. You can try it too. You can look on a calculator and try it. That's all it really means. And now we take the antiderivative or the integral of this because it's simple. Just use the power rule of antiderivatives. So we add 3 instead of subtracting it. We add it to it. We get u to the 3 over 2. But we're not going to leave it there. We're going to take this and we're going to do just like we do with the derivative, but the only thing that's different is we flip it. We do 2 over 3. That's terrible too. Let me fix this. Oh, that's terrible too. What's wrong with me? There. Then we can either put this in brackets, or if you got numbers here and here on the integral, you can put this in brackets and do that. But what we really should do is put this in this and multiply it by 1/3, because that 1/3 is just not going nowhere. But now we got to do this, which is a real pain in the keister. But what we could do before we do anything is simplify this. Okay? So to simplify this, we just multiply 2/3 by 1/3. And that's just simple. Just multiply across. So 2 times 1 is 2 over 3 times 3 is 9. And that's simplified. Then we can put a parentheses, re-put back in the u, which is 11 plus x cubed to the 3 over 2 power. And then we have to put a plus c. Easy, simple. That 9 is terrible. Hang on. Yeah, that's better. Easy, simple, and not a lot of paperwork. You can, and once you get really good at this, you could do it inside your head. But it takes practice. It takes dedication and practice. You gotta do it over and over and over again to get this good. Get good at doing all this just in your head. But I'm not even at that level. But the teachers that are teaching you are. So because they've done this, they've taught this type of stuff over and over again, and you can be this good too. Just use this method over and over again. Practice, practice, practice. That's all it takes. Is practice. Now, what do we do? What did we do? Really? We just did a little calculus 1. We did a little derivative right here, antiderivative right here. Actually, we simplified really because we have a radical. So first we simplified, then we took the antiderivative, and then we did a little bit of algebra. And that gave us a simplified version. If it's not asking for a simplified version, then don't do that. Just stick with this and just get 1 over 3 times 2 over 3. And then this type of put in the expression 11 plus x cubed to the 2/3. Or 3 over 2. Plus c. Either one of these is correct. I like the simplified version because it's not as many fractions, not as much crap. But if you if your teacher or your computer more or any other simulation or problem, textbook problem, they probably just want it in this form right here. So just put it in that form, and that's about it. This is a very easy problem for Calc 2 students. A little harder for Calc 1 because you're not used to them yet, but if you follow my advice, this problem becomes easy, simple, not very hard. Thank you for watching. Please comment in the section and tell me if you think my method is easy or difficult, or if I'm just if I'm playing correct. I'll see you next time.